Hey there! Aderis Energy is so excited to launch its Wiretap desktop app. In part two of my conversation with Brad and Bob, we are going to open up the Wiretap app and learn how to use it. Built within the Wiretap desktop app, we have some tutorial videos, so you can always reference these if you ever need help using the product. These will walk you through some tips for success and how to use the app as well as interpret some of the data. So first what we'll do is we'll go to the existing Modbus devices monitored by others. And what we'll want to do is first select from this drop down here. And I'm connected into this USB serial port. So you'll need a USB to serial connector. These are commonly found. They're going to be available through our website. Technicians use these all the time. So this is not some sort of special equipment you need. This is a really commonly used piece of equipment and inexpensive as well. So we'll go ahead and we'll click on that. And then what we'll do is we'll click on Start Listening. And this will listen to the communication between the devices that I've tapped into.
So what you're seeing here, Christine and Bob, is where it says COM port 9, all of these hexadecimal values that are coming back, this is the raw data stream that's coming back from the device. And then what Wiretap does is it separates that string of hexadecimals serial data out into a request and then a response. And so the request is what is coming from the data logger, where it's basically saying, hey, give me some information. And then the response is the device sending that information back. And we show this as, again, we're trying to make Modbus easy. So, one of the biggest problems when you're in the field and you're trying to communicate with devices is that you don't really get any feedback whether things are working or not. And so this is a way to see in real time that you're actually capturing information. And so we have some little counters at the top here. We have found one Modbus device, an ID. We have received 4 messages, and we have decoded 4 registers. So we know that we have actionable information here that we can use. And so now if we switch over to the registers tab, it's actually going to show us what those registers are. So we have a device with ID 1 in this case. And if we had multiple devices, we could just use that drop down to switch between them. So like think of a string of string inverters where we might have 12 string inverters. And if the Modbus IDs were 10 through 22 or something, we would see those here. And then the registers that are coming back from each device ID are down below. And so register 0 is giving us a 65 value as an int 32. And register 1, we're also seeing a 65 value as an int 16. So this is probably a 32-bit register in this case. And it's just using 2 memory spaces, 0 and 1. And that is the type of information I think that really, throws a lot of people, is about, the register spacings and whatnot. So we give you a preview of what these hexadecimal values look like when they're mapped into different data types. So register 2 is another example here. We have a 255 value coming back as an int 32, but then we can also see it show up in register 3. And so this is also an example of a 32-bit register that's being mapped across 2 registers. There you go. That's how this works.
That's great, Brad. I have a question. So for like some more complex devices like RTAC, like SEL relay, which they are able to communicate with multi different protocol. when we scan the devices, we only can see that IP address for the port communicating with Modbus, correct?
Right. So if we go home and if we go back and do a network scan sample here, so instead of doing a serial listening, we built out Wiretap to also have the ability to scan networks for information. And this does work a little bit different than the listening. This is truly more of a discovery. So it looks like, Christina, you've configured the Ethernet directly below the Bluetooth. There we go.
Yep.
So you would configure your local network port on your laptop, just like you would with any time you're connecting to another network. And then once you're on this network, we are going to scan a range of IP addresses. And so our test device here is set up 1 through 10. And instead of just looking at one IP address, you can use comma, or you can use hyphens in order to do a range. And then Modbus typically works over port 502, but there are cases where that's different. So what we're going to do is we're just going to hit scan for devices, and it's going to look at those 10 IP addresses and find, is there anything that, number one, is it on the network? And number two, does it have a port open for Modbus? And so here we go. We actually have 2 devices, 5 and 10, that are both on the network actively, and the Modbus port is open. So now that I've found a device, I can simply search for registers. So Modbus supports not only a device ID, that you could have multiple device IDs at a given IP address, although it's typically one, but you also have different register types. And most devices use holding or input registers, so we have defaulted to that. So we're just going to use holding registers, and now we need to do a range of registers that we want to ask for. And we can just do 0 through 10 on our demonstrator here, but you can scan 100 if you want to. It'll just take longer. So one of the advantages of the software here too is that, and there we go, we've already found some values. So one of the advantages of this is that with other software, when you call a device and you say, hey, give me all the data from registers 0 through 10, if there is a register that is not mapped in, it will cause the entire scan to fail. And because basically the device doesn't know how to return information from it. And you can see that we actually have that situation here with register 4 and I think beyond. Here are registers 4 through 10 that don't have any data in them. Potentially that would have failed and not returned any data. So Wiretap is intelligent, and it actually goes out and it scans each register in the range and then brings them back. And it allows you to scan a very large range of registers without having to know where those reserved spaces are that are going to cause your probing to fail. And so this too is a huge time saver by just being able to say, just show me what's there and let the software figure it out. And so so this too, once you have an IP address, you can test different device IDs, different register types, different register ranges. We've even built in some advanced functionality for devices that have different, what they call word and byte orders, or endpoints, and that's with an E, not an I. And so you can play around with those things too if you have a device that's really, non-standard, and that does happen. So so this is a really easy way. Just point the device at an IP address that you found, scan a range of registers, and you can start to get an idea of what what values are there to support your reverse engineering.
That's great. Yeah. So if just I'm curious about that. So if we are using, for example, the port 25,000, which is for DMP3. And we have a DMP3. I know we cannot go to the register because it's not set up, but we can see those devices as a DMP3 too. We can at least scan it.
You can, yeah. That's actually a really great point, Bob, is although we don't currently support other protocols in here like DNP3 or OPC UA, you could use it to find devices and test for those open ports. That is absolutely true. And so this, long term, we see this software as being kind of a Swiss Army knife for communications, testing, and commissioning on site. And it really is made for technicians who are trying to access devices and make sure that things are talking properly and remove some of the complexity that's involved with other software where you really have to know a lot about what you're doing. And here it is really a minimum amount of information, how to join the network, what ports you might be looking at, and then you can really do these very fast, broad tests of what's available. And that's a great point. You can scan for non-Modbus open ports. Absolutely.
Yep, that's great.
Thanks so much for watching. Don't forget to download the Wiretap app today.